Hello, welcome. Let's try to solve another Leetcode problem. 1042 flower plotting with no adjacent. So first, let's try to understand the problem. And let me make a drawing first. Maybe, yeah. So we're gonna have, let me just choose this kind of drawing. Yeah, so we have a graph like this. So it's gonna be the node of 1, 2, and 3. Now we are going to color it, and we have 4 different colors. So for the first one, maybe we want to color it in red, so it's gonna be number 1. And for the second one, maybe we want to color it in blue, so it's gonna be here. And for the third one, it cannot be red and blue, so it cannot be red and gray, so it must be another color. Maybe I'm gonna choose blue. Yeah. So the idea is just like color the graph. So it's like coloring a map. If we are having a map and we're gonna have a different color for the different countries. Yeah. And this problem is exactly the same. Yeah. So what are we going to do is that we're gonna build a graph. So because we have this kind of a path, so we can build an undirected graph. And after we build the undirected graph, and we're gonna try to check the node one by one. So for the first node, for example, this is 1. And how many colors? We have 4 different colors. So we have 1, 2, 3, 4. So we have 4 different choices. We can choose any one of them. Maybe we're gonna just choose 1. And then we're gonna color the next. It's gonna be this node 2, because this 1 has already been used and it is connected, because 2 is connected to node 1. So except for the red, we can use other colors, maybe 2, 3, or 4. So we're gonna choose 2. It's gonna be green. Yeah. Now we're gonna check the last node. So for the last node, it's gonna be the node 3. We cannot choose red and gray, so we have to choose another color, maybe 3 and 4. So we're gonna choose 3 or 4. It's gonna be the final result. So for the color array, it's gonna be a 1, 2, 3. We just need to return this kind of array. But how can we check if this color is used or not? We can directly use a set. So for example, from the beginning, we have a set of like this set 1, 2, 3, 4. But while we are coloring the first one for this node 1, we didn't use any of the color. So this means so the set 1, 2, 3, 4 gonna minus the set. So from the beginning, the set gonna be 0. And how can we represent that? We just use a color array. So we have a color array. So inside the color array, we're gonna set it always to be 0. Yeah. This means we didn't use any of the colors. Yeah. So for example, we have 1, 2, 3, and we're gonna initiate it as 0, 0, and 0. So for the first one, as this node, for the first one, this node 1, 2, 3, both of them are zeros. Yeah. So while we are coloring this first one, we're gonna check its neighbors. So its neighbors gonna be 2 and 3. So what about 2 and 3? It is 0 and 0, so it is okay. Yeah. So we just need to use this set like 1, 2, 3, 4 minus a set 0. Yeah. So except that 1, 2, 3, 4, we just need to pop a random value. For example, we're gonna pop 1. So it means for the node, for the first node, we're gonna have a color of 1. Yeah. And then we're gonna check the next for this node 2. And for the node 2, we're gonna check its neighbors. So it's gonna be a node 1 and 3. Yeah. Because for node 1 and 3, node 1 has a value of 1, and node 3 has a value of 0. So we have 1 and 0. So we're gonna use this set 1, 2, 3, 4 minus the set 1, 0. So what is left behind? Yeah. So what we left behind is that we're gonna we're gonna have 2, 3, and 4. Yeah, because 2 and 3 and 4 is not inside this 1 and 0. So we're gonna choose 2, 3, 4. We're gonna choose a random color, and maybe it's gonna be 2. So we're gonna choose this 2. So from here, we're gonna color it as 2. Now let's go to the next. Yeah, so this node 3 gonna be the last. And for this one, we just want to choose the color. Yeah, because its neighbors is 1 and 2. For node 1 and 2, we have color 1 and 2. So for the set 1, 2, 3, 4 minus the set 0, 1, and 2. So what's gonna be the result? So the result gonna be 3 and 4. We just need to pop out a value maybe we're gonna pop out 3, so 3 gonna be the last possible result. Yeah. Now let's just continue to solve the problem. But before that, let's just try to check some set. Yeah. So we have some kind of a set operation. So for example, we have set 1, 2, 3, and 4, and we can use minus another set. So for example, we're gonna prepare a 0 and 1. So what is the result? So the result is going to be 2, 3, and 4. Let's just check that. So as you can see, the result is 2, 3, and 4. So this is just why we can use the set operation to solve the problem. Yeah, maybe we want to minus a set 0, 1, 2, 3. So what's going to be the final result? So the final result is going to be set 4. And then we can pop out the result. It's going to be a number 4. Yeah, because we can do for the set, we can do the pop operation. So what's going to be the final result? So it's going to be a number 4. As you can see, the result is going to be 4. So this is exactly what we're going to use for our algorithm. We're going to use the set operation. We're going to use the set minus operation. Basically, it means the set difference. First of all, let's just try to build a graph. Because for this problem, even there's no path, even there's only one node, definitely we're going to color it. So we will not use the default dict with list. We're going to use a 2D array. Inside we're going to prepare an empty array. So I'm going to prepare how many rows. So for r in range with n. So that's going to be the number of rows. Yeah. So this is going to be the adjacency list. Now let's just build the graph. So for uv, inside the path array, and gu minus 1, because our graph gonna be for all the node, it's gonna be starting from 0 to n minus 1. So we're gonna use gu minus 1, append v minus 1, and similarly gv minus 1, append u minus 1. So this is gonna be the final graph. Now we can use this graph to solve the problem. We just need to enumerate the graph. Yeah, so let's just enumerate the maybe just the index and all the nodes. It's gonna be inside an array. So for I array, enumerate the graph G. Yeah. Now we want to check the color, but before that we need to initialize the color array, because finally we're gonna return this color array. So it's gonna be 0 times n. Yeah. And now we're gonna prepare the color array. So for the color I, so for this I, it's going to be color 0. Yeah, so for color 0, actually it means for the node 1. Yeah, so for color 0, we're going to use a set. As I explained earlier, we're going to use a range from 1 to 5. It means basically it is a node from 1 to 4, 1, 2, 3, and 4. And we're going to use minus. It means the difference of another set. So we're gonna prepare a set. So this set is gonna be a color. Let's use index j. So for j in range, j in graph G with let's just use this array. So for j in array, so j is all the node, and for each of the node we have a different color. If we minus this different color, it means what we left behind. Yeah, so this is what we left behind, and we just need to pop out that value. It can be any value if that is possible to color. Yeah, definitely we can color it, because for each of the node, it has at most 3 incoming and outgoing edges. Yeah, so this means we have 4 different colors. Definitely we can color it. Yeah, so we're gonna pop out this value, and this value gonna be the color. Finally, we just need to return the color array. Yeah, I hope you understand the problem, because in this kind of array, actually it is all the possible nodes. Yeah, so for all the possible nodes, we're gonna check the color. So for all those possible nodes connected to current node, it may have different colors. We're gonna use all colors minus the current color. It means what left behind. Yeah, it is just in this example. So for node 1 and 2, it has already colored 1 and 2, and for node 3, we just need to use 1, 2, 3, 4 minus the color. It's going to be 0, 1, and 2. So it's going to be 3 and 4 left behind. We just need to pop out any one of them. It's going to be 3 or 4. Yeah. Now let me just run it to check. As you can see, it works. Now let me submit it. Yeah, as you can see, it works and it's pretty fast. Now let's analyze the time complexity. For here, the time complexity is going to be O(n). N is the length of the path. It is 10 to the power 4 times 2. It is okay. And for here, it is still O(n). Even here, we use a set operation, but this kind of yeah, because for here, definitely this is we're gonna check that this is O(n). And for here, we have the set operation. But inside of the set, it only has 4 numbers, and we're gonna minus another 4 numbers. So basically from here, we're gonna calculate it only as O(1), because there are not so many numbers inside the set. There's only 4 numbers, and minus maybe 3 or 4 numbers, it doesn't matter. So the time complexity gonna be just O(n). But this n is a number of 4, so we're gonna call it O(1). So the time complexity gonna be O(n). Yeah, that is why it is so fast. So thank you for watching. See you next time.